Hey everyone and welcome. Ever wondered how you could build a team of AI agents to automatically collect, analyze, and visualize data for you? Imagine specialized AI assistants, each taking a piece of your data pipeline and then collaborating to deliver powerful insights. That's the power of multi-agent systems, and today we're going to build one for data analytics using Google's amazing Agent Development Kit, or ADK. Data analytics can be complex, involving many steps from gathering raw data to generating meaningful reports. Now, doing this manually or with monolithic scripts can be inefficient and hard to scale. But what if we could delegate these tasks to intelligent, autonomous agents? In this tutorial, I'll show you exactly how to build such system. We'll leverage the strengths of Google's Gemini models and OpenAI's powerful models, all orchestrated by the Google ADK. By the end of this video, you'll understand the core concepts of multi-agent system and Google ADK, how to design an architecture for a data analytics multi-agent system, how to implement different types of agents in Python using ADK, including data collectors, LLM-powered analysts, and visualizers, and how to integrate both Google's and OpenAI's LLM APIs into your agent, and how to make these agents communicate and pass data to produce a final analytical output. A multi-agent system, or MAS, is essentially a group of intelligent agents that interact to solve problems that are beyond the capabilities of any single agent. Google's ADK 18 is an open source framework designed to simplify building these sophisticated multi-agent systems. It's flexible, modular, and integrates tightly with Google's ecosystem, including Gemini models, while also being model agnostic enough to let us plug in other LLMs by those of, in this example, OpenAI. Alright, let's look at the big picture. This is the architecture of the data analytics multi-agent system we'll be building today. We have several specialized agents working together in a pipeline. The diagram should visually emphasize the orchestration layer, reinforcing that agents are part of a managed system with ADK providing the control flow. Think of it like an assembly line for data insights. Raw data comes from one end and a visualized report comes out of the other, with each agent performing critical steps. So first we have our data collector agent. Its job is to fetch raw data. This could be from a CSV file, a database, or even an API. For today, we will be simulating fetching some sample data. Next, the data preprocessor agent. This agent takes the raw data, cleans it, transforms it into a usable format, maybe does some initial structuring. Think of it as getting the data ready for the star analyst. Finally, the visualization agent. This agent takes the analyzed data and insights from our LLM agents and creates charts or graphs using the libraries that we define in the code, like Matplotlib or Seaborn, to present these findings visually. We have the same thing in a table form to kind of easily understand the data collector agent, the core responsibility being like to the fetch to raw data, and just show the ADK class of it and the tools and library used in it. And for the LLM analyst agents, we do use the API keys instead of the Vertex AI SDK and the LLM Lite, but these two are something to think about while building different kinds of agents. So when it comes to the data flow, it'll flow sequentially through these different agents that we've set up. the data collector passes the data to the preprocessor, which then passes it to the LLM analyst agents, and then their combined insights are then fed into the visualizer or the visualization agent. And then we'll use ADK's workflow capabilities, specifically a sequential agent to manage this flow. Data will be passed between agents using invocation context state. This is a key ADK feature that simplifies pipeline orchestration. While we use sequential agent here, it's worth noting ADK's flexibility. For instance, if two LLM analyst tasks were independent and could process the same input data simultaneously, a parallel agent could be used to run them concurrently, potentially speeding up the pipeline. This choice depends on task dependencies and performance goals, highlighting how ADK supports. So what makes Google's ADK 18 great for building these systems? ADK is an open source Python framework and also has Java support that simplifies designing, building, and deploying AI agents. It's specifically built with multi-agent system in mind. The key benefits kind of include modularity. You can easily define specialized agents. And in terms of the orchestration, it has built-in support for complex workflows using workflow agents. The LLM integration bit, of course, it's built by Google, so it's optimized for Gemini, but importantly, it's marketed as model agnostic, which means this allows for easy connection to other LLMs like OpenAI models, and often through wrappers like LiteLLM. This flexibility is a significant advantage for developers who want to use different LLM providers or switch between them. And coming to the tooling bit, you get to equip agent with tools which are essential Python functions to interact with external systems or perform specific non-LLM tasks. We will primarily work with a few core ADK classes today, which are the base agent class. This is the foundational class for all agents. We've used this for agents with custom Python logic, like our data collector, preprocessor, and the LLM analyst for more explicit control in this tutorial, and the visualizer. Then you have the LLM agent, a specialized agent for interacting with large language models, which will use base agent wrappers for LLM today for clarity. LLM agent is powerful for direct LLM tasks, especially when combined with tools. The sequential agent is a workflow agent that runs a list of sub-agents one after the other. This will be our main orchestrator, ensuring our data pipeline flows correctly. And then tools. These are Python functions that we define and can give to our agents, allowing them to perform actions beyond just simple LLM interactions. This could be like fetching data or calling other APIs. And we have the runner or the ADK app, which is used to execute and potentially server agent application. A crucial part of MAS is how agents communicate and share data. ADK makes this straightforward, especially within workflows managed by agents like sequential agent. Sub-agents in a sequence can pass data using a shared invocation context, specifically its state attribute. One agent writes its output to the state, and the next agent in the sequence can read it. This mechanism is central to our pipeline. And just to talk about the ADK philosophy, ADK aims to make agent development feel more like software development, providing structure, control, and a clear path from development to deployment. This is incredibly helpful when moving from simple prototypes to more complex production-ready systems. Well, let's get our hands dirty. First, ensure you have Python 3.10 or newer installed. We'll need to install the Google ADK package along with libraries for Google Cloud. But you don't need to do that if you're just using the API. And yeah, you can just use the OpenAI API here too. Our data manipulation and visualization tools are keeping it really simple. So Pandas, Matplotlib, and Seaborn. So I'll be sharing the entire code with you, the GitHub repo, and some resources for you to kind of deep dive into this. But in the video, I'll just be doing a high-level overview of the different parts of the code. So we'll begin by going through the main underscore orchestrator Python file. The script which I'm about to show will define our agents, assemble them into a pipeline and run the pipeline. Essentially, we'll begin by importing the necessary ADK classes, the sequential agent for orchestration, the base agent as the foundation for our custom agents, and the invocation context for managing state and context during execution. And then the specific agent classes that we'll define shortly. First, we'll initialize instances of each of our agents. For the LLM agents, we'll pass the model names they should use. Then the core of our orchestration will create a sequential agent. This agent takes a list of sub-agents in its constructor and will execute them in the exact order we provided to. I'll just show you the Python code in my IDE. So I have some sample data, and then this is where I initialize my agents, kind of define the pipeline, and set up whatever I previously mentioned. For this tutorial, we're focusing on the agent logic and their direct execution via the async and pipeline .run. ADK also provides runner and ADK app classes for more complex execution scenarios, or for serving or servicing agents as applications, where we might explore in a future video, I suppose. Our first agent, the data collector agent, it'll be a base agent. Base agent is the go-to for implementing custom Python logic that doesn't directly involve an LLM as its primary. So that's the class that we define as a base agent. The core logic of the base agent resides in its run method, run async method. This asynchronous generated method receives an invocation context which provides access to the shared session state. In this agent, the run async will simulate loading data from a local CSV using the pandas library, and after loading it, it'll convert the data frame to a JSON string and then store it in its session. This makes the raw data available to subsequent agents in the pipeline. The agent then yields an event to the signal to signal its completion or any errors. Next up is the data pre-processing agent, also a base agent in its run method will first retrieve the raw data that the collector agent stored in the session state. Using pandas, it will then perform necessary pre-processing step. This could include handling missing values or converting data types or restructuring the data. But for our demo, we'll keep it like super simple. Just do some missing numerical values and ensure that our date column is date time formatted, and the process data frame again is converted to a JSON string, will be stored back into the session state, this time under a new key which is called process data JSON, ready for the analyst agent. Now for our first analyst, the Gemini analyst agent, making the data flow into an LLM explicit. We'll implement this as a base agent that uses the Gemini API to call the models. In this case, 1.5 Flash. This approach demystifies how dynamic data from the state is incorporated into the LLM prompt. The agent will retrieve the process data JSON from the state. It will then construct a detailed prompt instructing Gemini model to analyze this data for key trends, focusing on monthly revenue changes and top products. The textual analysis received from Gemini will be stored in the session state. Our second analyst, the OpenAI analyst, is also a base agent. We will use an OpenAI model, like in this case I've used GPT-4o Mini from the OpenAI API. This agent will also read the process data from the state. Its prompt will direct it to perform a different kind of analysis. For example, identifying potential anomalies or outliers in the sales data and explaining any unusual patterns. And the agent will store its finding in the session state again. Our final agent in the pipeline is the visualization agent. This base agent is responsible for creating visual representation of our data and analysis. It'll read the processed data JSON from the session state and also fetch the textual insights from Gemini analysis and the OpenAI analysis. So it'll use Matplot and Seaborn, and it'll generate a couple of plots, for instance, a line chart showing sales over time and a bar chart illustrating revenue by product. A key aspect here is that it can programmatically incorporate snippets from the LLM generated analysis into the chart titles or annotations, demonstrating a true synthesis of the outputs from different agents. This is a powerful way to show how agents can build upon each other's work and not just pass raw data. The generated plots will be saved as images in this case in the results directory, and you could configure it as how you want, and you can add as many agents you want here and orchestrate in any way you want for your specific use case. Now returning to our main the orchestrator script, we've defined all our agents. The sequential agent name pipeline is configured with these agents in the correct order of execution: the data collector, the preprocessor, then the Gemini analyst, then OpenAI analyst, and finally the visualizer. To kind of run the pipeline, we create an invocation context. This context object is vital as it carries the shared session that our agent uses to pass data. Then we simply call the pipeline.run. This asynchronous method executes the entire sequence. We can iterate through the events yielded by run async to see the messages from each agent as it works. And after the pipeline completes, we can inspect these session states to see the final output, like the LLM analysis and the paths to our saved visualization. The product revenue image and the sales revenue over time image. And as our pipeline runs, you'll see the print statements from each agent indicating its progress. This is a simple form of logging for our tutorial. ADK itself provides an event-based output stream, which we're iterating over for a more robust logging and production system. You typically inbuild Python's built-in login module within each agent's run asynchronous method. Furthermore, ADK supports callbacks like agent callback, after agent callback, and before tool callback and after tool callback. These callbacks can be really powerful for implementing detailed login, monitoring state changes, or even enforcing policies at different stages of an agent's life cycle without modifying the core agent logic. For instance, an after tool callback could log the arguments and results of every tool call. For today, our print statements suffice to show the flow, but keep these advanced logging capabilities in mind for some kind of real-world application. Our sequential agent has now orchestrated the entire pipeline, culminating in the visualization agent. The final agent successfully accessed the pre-processed data and textual analysis generated by both the Gemini and OpenAI models, all of which were seamlessly passed along via the shared convocation state. Here are the fruits of our labor, agent's labor, I would say, the visualizations. The first chart, which is the sales revenue over time, clearly shows the revenue trends across different product categories. And if you notice how the title kind of dynamically incorporates a snippet from Gemini's trend summary, a direct result of inter-agent collaboration, we can observe a steady increase in gadget Q1 sales, while widgets saw a slight dip. The second chart, which is the product revenue, total revenue, or total revenue by product, gives us a breakdown of performance for individual products. Again, the title includes a brief note, this time potentially relating to an anomaly flagged by OpenAI agent, adding another layer of insight directly on the visual. This output beautifully demonstrates the collaborative power of our multi-agent system. Data was collected, pre-processed, analyzed from two distinct LLM perspectives, providing complementary insights, and finally all this information was synthesized into these clear, informative visual reports. The real beauty of this multi-agent approach lies in its modularity and specialization. Each agent focused exclusively on its designated task, and if we decided tomorrow that we wanted a different type of visualization, or perhaps to add a third LLM for another analytical angle, we could simply modify the visualization agent or introduce a new analyst agent. The rest of the system could remain largely unchanged. This makes the system flexible, maintainable, and easier to scale or adapt compared to a single monolithic application. And there you have it. We've successfully designed and implemented a functional data analytics multi-agent system using Google's Agent Development Kit. We've journeyed through creating specialized agents for data collection, pre-processing, leveraging the analytical power of Google's Gemini and OpenAI's model, orchestrating their complex interactions, and finally generating meaningful visual outputs. You now possess a solid foundational understanding and practical skills to start building your own sophisticated multi-agent system using ADK. If you found this tutorial valuable and it helped clarify how to build these exciting systems, please give this video a thumbs up. It genuinely helps the channel reach more learners. Don't forget to subscribe and click the notification bell so you're the first to know about the future tutorials on AI, data science, and multi-agent system, and more advanced ADK topics. All Python code you've seen today, including the agent definition and the orchestrator scripts, is available on YouTube. You'll find the link in the description below, and I strongly encourage you to clone the repository, experimenting with the code, try different data or LLM prompts, and expand upon it. Do you have any questions about this tutorial, or perhaps ideas for another multi-agent system you'd like to see built? Drop a comment below. I'll make it a point to read them all and encourage your feedback. The system we built today runs locally, which is perfect for development and learning. However, for real-world production-grade applications, you'll need to consider scaling and deployment. ADK agents are designed to be containerized, for example, using Docker. This allows them to be deployed across various environments, including serverless platforms like Google Cloud Run, container orchestration system like GKE, or for more managed enterprise-scale operation, Vertex AI Engine. Vertex AI Engine is in particular a powerful option as it's built to host, manage, and scale agents, offering features like managed conversation session, integrated testing tools, and ensuring reliability and security for your deployed ADK agents. The analytics pipeline that we implemented, which involved data collection, pre-processing, analysis for multiple perspective, and reporting, is incredibly versatile and has application across numerous domains. For example, automated business reporting. Imagine agents generating daily or weekly sales summaries, automatically highlighting key trends identified by one LLM agent, and then flashing anomalies detected by another, then compiling it all into a digestible report for the business stakeholders. The next one could be financial document analysis. A team of agents could be tasked with extracting critical data from lengthy financial filings, another agent summarizing key financial health indicators, and yet another flagging potential risk or compliance issue based on predefined rules or LLM reasoning. Agents could automate the process of gathering data from experiments or public data sets, passing it to specialized model-based agents for analysis, and even assisting in hypothesis generation or literature review. And finally, the customer feedback analysis. One agent could collect customer reviews from various platforms, another perform sentiment analysis, a third identifying recurring themes or topics using NLP, and finally, agents summarizing the overall customer sentiment and key issues. These examples illustrate how breaking down complex analytical tasks into specialized agent function can lead to powerful automated solutions. Google ADK is a fantastic and robust framework, especially if you're working with Google Cloud ecosystem. As you continue your journey into multi-agent system, it's beneficial to be aware of the broader landscape. You might encounter other open source frameworks, for example, Spade, which is Smart Python Agent Development Environment, is a mature platform based on XMPP for agent communication, offering a different paradigm. Frameworks like LangGraph or True AI, which focuses on creating agentic workflows, are also gaining traction, and significantly, ADK is designed for interoperability and can connect with agents or tools built on the other platforms as well. Understanding ADK not as an isolated solution, but as a component with larger evolving ecosystem of AI development tools, enhances the value of the skills you're learning. The core principles of agent-based design, modularity, specialization, and coordinated interaction are the key. Keep exploring, keep learning, and keep building.